Thanuja, your physics teacher. This is my second class for you, and here I am introducing our physics, that is our subject physics to you. Okay. The word physics is derived from the word physis. The word physics is derived from the Greek word physis, that means nature. Okay, nature. Everything in the nature. For every happenings in the nature, there will be an answer in physics. So the word physics is derived from the Greek word physis. The study of nature and natural phenomena is dealt in physics. What is dealt in physics? What we are dealing with in physics? The study of nature and natural phenomena. Hence, physics is considered as the most basic of all the subjects. Physics is considered as the most basic of all the sciences, all the other sciences. Okay. While studying physics, we will be following two methods, unification and reductionism. These are the two approaches in studying physics. Unification and reductionism are the two approaches in studying physics. Attempting to explain diverse physical phenomena with a few concepts and laws is unification. Attempting to explain diverse physical phenomena with a few concepts and laws is unification. Meaning, with one law or a few laws, we can explain vast things. This is called unification. Okay, for example, Newton's universal law. Newton's universal law of gravitation explains many things. So this simple law explains many things. This is unification. What are the things explained by Newton's law? Motion of freely falling bodies towards the earth, motion of planets around the sun, motion of moon around the earth, and so many things are unified into one thing. So this method is unification approach. Okay, this is the unification approach. Now, an attempt to explain a macroscopic system in terms of its microscopic constituents is called reductionism. Okay, an attempt to explain a macroscopic system in terms of its microscopic constituents is called reductionism. So this we will be studying in thermodynamics, which is in your 8th unit, and thermodynamics was developed to explain macroscopic properties like temperature, entropy, etc. of bulk systems. Macroscopic properties, temperature, entropy, pressure, these are all things macroscopic, and this is explained. These properties can be explained in terms of microscopic approach. Okay, in terms of microscopic constituents of the bulk system by kinetic theory and statistical mechanics. So here a macroscopic system is explained with the microscopic things such as kinetic theory and statistical mechanics. This method or this approach to physics is called reductionism. Now, branches of physics. Physics has a lot of branches. Physics has a lot of branches. We already studied that physics is the basics for all the other sciences, and from physics only many things are new technology, everything are due to physics. Okay, so now modern physics. In classical physics, mechanics, thermodynamics and kinetic theory of gases, optics, electricity and magnetism, acoustics, astrophysics, relativity, etc. are given. Even mechanics have subdivisions, statics and dynamics. Dynamics is divided into kinematics and kinetics. And in modern physics, you will be studying about quantum physics. Even in quantum physics, non-relativistic and relativistic quantum physics, then atomic physics, nuclear physics, molecular physics, high energy physics and condensed matter physics, that is solid state physics. These things pave way to our computer science. New inventions were made based on this. So condensed matter physics, our electronics, electromagnetism, all these things are taken from this condensed matter physics. So classical physics, branches and explanation for the branches is given in the textbook. So what is classical physics? It refers the traditional physics that was recognized and developed before the 20th century. The things which were developed before 20th century were taken under classical physics, and classical mechanics is the one of the branch in classical physics. The study of forces acting on bodies, whether at rest or in motion, is called the classical mechanics. The study of forces acting on bodies, whether the bodies are at rest or in motion, are called the classical mechanics. Thermodynamics, the study of relationship between heat and other forms of energies given in thermodynamics. Then optics is the study of light. We will be studying about light in optics. Electricity and magnetism, the study of electricity and magnetism and their mutual relationship will be studied here. And acoustics, what is acoustics? The study of production and propagation of sound waves. And astrophysics, the branch of physics that deals with the study of the celestial objects. And relativity, one of the branches of theoretical physics which deals with the relationship between space, time and energy, particularly with respect to objects moving in different ways. These things will be studied in classical physics. Now, modern physics. Modern physics refers to the concepts in physics that have been surfaced since the beginning of the 20th century. In this, quantum mechanics means the study of discrete nature of phenomena at the atomic and subatomic levels. Study about micro objects, electrons, protons, all these things, the behavior of these things will be studied here. And atomic physics, the branch of physics which deals with the structure of the properties of atoms. This will give the structure of properties of atoms, and this quantum physics will give you the structure and properties of the subatomic particles there. And condensed matter physics, nuclear physics, branch of physics which deals with the structure, properties and the reactions of nuclei of atoms. And condensed matter physics, the study of properties of condensed materials, solids, liquids and those intermediate between them. It branches into various subdivisions including developing fields such as nanoscience, photonics, etc. It covers the basics of material science which aims at developing new material with better properties for promising applications. And high energy physics, study of the nature of the particles. These are the branches given. Now, we are studying about the scope and the excitement of physics. What are the scope of physics and the excitement of? So, studying physics is an excitement Roentgen discovered X-ray accidentally. Is it not? Like that, discoveries in physics are of two types. Accidental discoveries. The scientist may not think of discovering that, but accidentally he might have discovered it. So, and the well-analyzed research outcome, and some scientists will be analyzing, they will be having a well-analyzed research and outcome of that in the laboratory based on the intuition thinking and prediction. For example, magnetism was accidentally observed, but the reason for the strange behavior of magnets was later analyzed theoretically. So, two methods, accidentally observed and the reason is analyzed theoretically. This analysis revealed the underlying phenomena of magnetism. So, while analyzing about the magnetic properties, we found why magnetism is there in such materials, and so with this knowledge we are able to develop artificial magnets in the laboratories. Okay, so first magnets were accidentally found, and the inquisitive mind which thought why this material has the magnetic property gives the answer for that, and based on that whether any more materials have this magnetic abilities was analyzed, and based on that we are able to make magnets artificially in the laboratories. Now, theoretical predictions are the most important contribution of physics to the developments in technology and medicine. Even some scientists theoretically predict this will be so. That may not be proved, but it will be so until it is proved now. Okay. See, Albert Einstein, our scientist Albert Einstein, predicted the formula for energy as E is equal to mc square, and this prediction was made in the year 1905, and it was proved experimentally in the year 1932 by Cockcroft and Walton, two scientists. Okay. So, just to make predictions, some scientists have the ability, they had the ability to predict something, and that may be proved wrong or right by the course of time. So, this is very important, predictions, theoretical predictions. Theoretical predictions aided with the recent simulation and computation procedures are widely used to identify the most suited materials for robust applications. So, some scientists may predict this thing will have this ability to withstand heat, or it can withstand power, pressure. So, these things will be predicted by scientists, then may be proved, and if it is proved right, it can be used for our applications. The pharmaceutical industry uses this technique very effectively to design new drugs. The pharmaceutical industry uses this technique very effectively to design new drugs, biocompatible materials for organ replacement are predicted using quantum prescriptions of physics before fabrication. Okay. See, the physicists will predict this material can be suitable for making organs artificially by studying the basic properties of the material quantum mechanically, can be used for these applications. Then experiments will be done on that, and based on that the material can be chosen for organ manufacture. First, the organs of human organs are now manufactured, isn't that? Manufactured, and they replace the original organs, defective original organs. The experiment and theory work hand in hand, complementing one another. So, first theory will be predicted, then the experiment will be done, and theory and experimentation are complement to each other. Physics has a huge scope as it covers a tremendous range of magnitude of various physical quantities. What are the physical quantities? Length, mass, time, energy, etc. All these things are dealt in physics. So, physics has a huge scope. It deals with the systems of very large magnitude, as in astronomical phenomena, as well as those with very small magnitude involving electrons and protons. Okay, so physics deals with the very huge objects of the size of a star or universe. Like that range of time scale, astronomical scales to microscopic scales are used. That is, time can be in 10 power 18 second to 10 power minus 22 second, and very high time to a very micro time. Okay. The study of physics is not only educative but also exciting in many ways. Study of physics does not only give us education, but it is an excitement. You can have pleasure in studying physics. A small number of basic concepts and laws can explain diverse physical phenomena. The most interesting part in physics is the design of useful devices based on physical laws. Okay, design of useful devices based on physical laws. For example, use of robotics, journey to moon and to nearby planets with controls from the ground, technological advances in health sciences, etc. Many physics has very vast applications in life. Use of robotics, technology, that is journey to moon. We can go to moon and come back from moon. Even we can go to nearby places. We can go to space, but everything will be controlled from here by using technology and technological advances in health sciences. Like that, carrying out, these are the scopes of physics, carrying out new challenging experiments to unfold the secrets of nature and verifying and falsifying the existing theories. We can have challenging experiments. We can take, some scientists may predict this is so, and we can take it as a challenge, and we can make experiments based on that, and that will unfold the secrets of nature. The challenges can unfold the secret of nature, and even we can verify the theories predicted by scientists or falsified. It can be verified true or falsified by using our experiments. Probing and understanding the science behind natural phenomena like the eclipse and why one feels the heat when there is a fire, or what causes wind, etc. We can give answers to all the natural phenomena. Even one can be walk. Why are you able to walk without slipping? That can also be explained in physics. And all the natural phenomena will be why there is a rain, why there is thunder, why there is lightning. All these things will be explained by physics. In today's world of technological advancement, the building block of all engineering and technological education is physics, which is explained with the help of mathematical tools. We can explain physics with the help of mathematical tools. Everything in today's world can be explained with the help. Everything in today's world can be explained in physics with the help of